This video will be studying about growth and decay of charge in CR circuit. Okay. We'll take two cases: growth decay of charge in CR circuit. Right. We will be taking two cases. The first one, charging of capacitor, means when the capacitor is being charged, and in the second case, when capacitor is being discharged. Okay. So the first one, charging of capacitor. Second one is discharge. So we'll be studying. We'll be finding the amount of charge on the capacitor at any instant, the current that is being flown in the circuit. Okay, we'll be finding potential across capacitor, potential across resistor, and many things. Okay, so coming on to our first case, charging of capacitor. See, we are drawing a general circuit. Okay, the battery. Okay, this point A, point S, this point, right, and the capacitor of capacitance C, the resistor, they are connected, right. Now in charging of capacitor, first we are charging the capacitor. Okay, so we are joining this point A and S. Okay, so this will not be having any use. Okay, now let at any instant, means we are joining this A to C at t equal to 0. This phenomenon is occurring at t equal to 0. Now let any instant Q be the charge on capacitor at t equal to t, right, and let I be the charging current. Okay, now what will happen? The potential that will be developed across C, let's say it is VC, and potential developed across R is R. Okay, you know that VC will be Q upon C. Q is the instantaneous charge, right, and VR will be I into R. I is instantaneous current. Okay, now by KVL, Kirchhoff's voltage law, what will be there? If you move across this circuit, what would be the equation? It will be, see, we are going from the positive plate, this is negative plate, right? We are going from positive to negative, means there is a decrease of potential. So we are taking in decrease of potential as positive. Okay, it will be plus Q by C. Then we are passing across the resistor, and there is also a decrease of potential, and we are taking it positive. So plus IR minus E, because it's the negative one and positive one, there is an increase and in potential, and we are taking it as negative, equals to 0. So from here you can write Q by C. You can write IR. Okay, IR is equals to just a second. This is actually IR. Just a second. Writing it here. IR is equals to E minus Q by C. Okay. So IR is equals to, you can write Q as sorry, this E can be written as E. This can be written as E by C. We are taking the LCM. Okay. Now I will be CE minus Q upon R. This is dq by dt, since it is an instantaneous current. Yeah. Now just rearrange this equation. Okay, so it will be dq upon CE minus Q is equals to dt upon R. You just need to integrate it. See that we are taking our interval is equal to 0 to t equal to t, and our growth of charge is initially the charge on capacitor is 0, and now at t equal to t our charge on capacitor is q. Okay. You now this is a simple integration. Okay, you need to integrate. This will be minus ln ce minus q from 0 to q equals to 1 upon cr. dt will be 0 to t, right? This will be minus log ce minus q minus log of ce. All these are base, right? Equals to t upon cr. This is basically a simple rearrangement. Okay, log e minus q upon ce base e is equals to minus t upon cr. Okay, now this will be now see this ce we are, which is what, q naught equal to q max. Why? Because if you see that this vc, what will be the maximum of value of vc? This will be e, means c is what, capacitance into potential difference across the plates. This is maximum ce. This will be the maximum charge on the capacitor, right? So we can take it as q naught or q max, you can say, right? This is also known as final steady charge on capacitor. Okay. Now rearranging this equation, okay, what you will get, 1 minus q upon ce is equals to e power minus t upon cr, right? So q upon ce is equals to 1 minus e to the power minus t upon cr. Okay, so q can be written as ce 1 minus e to the power minus t upon cr, or you can say q is equals to q naught 1 minus e to the power minus t upon cr. This will be your at charge at any instant on the capacitor. Okay, and this cr, this quantity tau, this is known as time constant of cr circuit. Right, and if you draw a graph between q and t, will be something like this. This is the value q on the y-axis, on the x-axis is t, and this value is a final steady value. Okay, this will be q naught, right? So yeah, this one is, and at t equal to cr, charge will be 0.63 q naught, right? You can put the value of t equal to cr in the equation, in this equation, q equal to q naught 1 minus e power minus t base cr, and you can get the value of q. It will be 0.63 q naught. Okay, just remember it. Okay, now we have got the charge. Now we need to find the value of current, okay, at an instant. Okay, it will be dq by dt. So we just need to differentiate q with t. So this will be I is equals to q naught by cr e to the power minus t upon cr, means I is equals to I naught e to the power minus t upon cr. will be your instantaneous current, right? One more thing, this is a direct equation, okay? You can derive it as well. I is equals to I naught e to power minus t by cr, where I naught is q naught upon cr is equals to I naught. How we have got this? We have done one simple thing, okay? See, this q naught, this can be written as c into e upon c into r. So this c gets cancelled out. E by r, what? This is actually your I naught, right? We have got current now. Vc, the potential difference across capacitor, it will be q upon c, and we know the value of q. It is q naught upon c 1 minus e to power minus t upon cr. Now Vc will be, this is what, c into e. Q naught can be written as c into e upon c 1 minus e to power minus t by cr. So Vc will be e 1 minus e to power minus t upon cr. E is what? It's also a maximum potential difference. Okay, we have got Vc. Now we need to calculate Vr. Vr will be I into R. Just put the value, put the equation of I. It will be E by R e to power minus t by cr into R. R gets cancelled out, so Vr will be E. This will be the potential difference across resistor, and you can draw the graphs as well. What will be the variation of this? It will be something like this. Okay, what will the graph of this? This is what? This is Vr. Again, graph will be something like this. Vc. Okay, you can draw the different graphs. So this was the first case, charging of capacitor. Okay, where we have found an instantaneous charge, instantaneous current, and other things. Okay, this current I, the current that is varying with time, okay, is known as transient current. Okay, means the current which is not steady with time. Okay, so this was all about growth of charge. Okay, or you can say charging of capacitor.